For the main question, I asked you to figure out how many times the universe doubled in size after dark energy first started to show its influence, and how many times it would double in size in the future before matter no longer has any significant influence on expansion. More precisely, for how many past and future doublings of the scale factor are they both at least 10% of the energy content of the universe. Let's think about a giant box of space that's expanding with the rest of the universe. We call this a co-moving volume. To start with, let's ask how large this volume was when dark energy only comprised 10% of its total energy. So at that point in the past, we know that this equation is true. Right now, 70% of the energy in any volume in the universe is in the form of dark energy. So, 70 parts dark energy and 30 parts matter. Now that looks like this. Back in the day, it was whatever the sum of dark energy and matter was back then. The overall amount of energy in the form of matter doesn't change because matter is spreading out with the expanding volume. Matter past equals matter now for a co-moving volume. But the amount of energy in the form of dark energy is proportional to the volume, and the volume of the box is equal to the length of its sides cubed. We can scale past dark energy according to the current dark energy content like this. And we can just use the scale factor of the universe as the side length of our box. In fact, let's just use R for the ratio of past to present scale factors. In fact, R is actually what we want to find. So our total energy becomes this. Put all of this into our original equation and rearrange, and we get this equation for the ratio of scale factors. Plug in our current 70 units of dark energy and 30 units of matter, and we get that the universe was 36% of its current size when dark energy had a 10% contribution. But I asked you how many doublings ago that was. So you need to double that 0.36 about 1.5 times to get to the current scale factor of 1. You can take exactly the same approach to ask when in the future matter will only have a 10% contribution to the energy in that volume. It'll happen when the universe is larger by a factor of 1.57, or about 0.7 of a single doubling. Add these two numbers together and you get that matter and dark energy both produce a significant effect for around 2 doublings. That's tiny compared to the 100 past doublings that have happened since the end of inflation, and the infinite number of doublings that will happen in the future. For the extra credit question, you were asked to figure out the number of years that this corresponds to. Now to do that, you need to integrate the first Friedmann equation over the scale factors that you got for the main part of the question. The answer is that overall, the two influences will be within an order of magnitude of each other for around 15 billion years. Now that may sound like a lot, but we find ourselves right in the middle of this very narrow logarithmic window. The solutions to both parts of the question are